exception hierarchy, try, catch, finally, and catch order rules. So understanding the exception hierarchy is the foundation of chapter 8, right? So everything extends from throwable at the top. Throwable has two direct children. Error represents serious JVM level problems like running out of memory or stack overflow from infinite recursion. So you generally do not catch errors. They indicate in situations the application cannot meaningfully recover from. Exception is the branch that you work with in normal programming. Exception itself splits into two groups. So one is unchecked, runtime exception and its subclasses. These represent programmer mistakes, things you should have prevented with better code. Calling a method on null, you should have checked for null. So accessing index 5 on a 3-element array, that's also a problem. You should have checked the length, and then dividing by 0, you should have validated the input. Casting a dog to cat, you should have used instance of first. So like this, so these are unchecked, runtime exception and its subclasses, okay? They represent programmer mistakes, okay? And things you should have prevented with better code. Java's position on this is the compiler will not force you to handle them, because the right fix is to write the better code, not surround everything with try catch block. So if you had to catch a null pointer exception everywhere, your code would be unreadable and the real bug would still be there, okay? And then there is checked exception, and then there is checked exception, okay? And it's not runtime exception. So these represent conditions outside your control, things that can go wrong even when your code is perfectly written. The file you are trying to read, it does not exist. It's not your fault. The database server is down, not your fault. The network connection dropped, not your fault. Java's position on this is the compiler will force you to deal with them, because ignoring them is not acceptable. You must either catch them or declare them with throws. The compiler is essentially saying, you know this can fail, so prove that you have a plan. Okay. So if we come to try, catch and finally structure and variants, the try, catch, finally structure is the main way Java handles exceptions. The try block contains code that might throw an exception. Catch blocks handle specific types of exceptions. The finally block contains code that always runs, no matter what happens. There is some flexibility in the structure. Both catch and finally are optional, but you must have at least one of them. A try block alone is not allowed. It causes a compile time error. You can write a try with a finally block and no catch. This is useful for cleanup tasks like closing files or database connections, while still allowing the exception to propagate to the caller. So if we come to the code, right, so we see a try block and then catch, IO exception E, catch exception E, and then finally. This is the complete form. The try block wraps the risky code. The catch blocks handle specific exception types. And notice the order here, IO exception comes before exception. That is intentional, and we'll cover why in the next slide. The finally blocks runs no matter what happens. Exception or no exception, return or no return. Okay. Second block is we see that try, then risky operation, then finally cleanup, right? So it's try with only finally. So this is perfectly valid. No catch block at all. So you use this when you want cleanup code to run. Close a file, release a connection, but you are happy for the exception to propagate up to the caller. You are not handling the exception here, okay? Just making sure cleanup happens before it travels further up the call stack, okay? And then we have try with only catch, right? The third block. So try, risky operation, catch, right? So try and catch. This is also valid. Finally is optional. If you have nothing to clean up, you simply handle the exception and move on. And then we have only try, right? So this is a compiler error, right? So Java requires at least one catch block or a finally block to follow it. The compiler will not allow a standalone try. So next one is catch order, most specific to least specific. So if you see, Java processes catch blocks from top to bottom, and it executes the first matching one. Because of this, order is very important. If you put a parent exception like runtime exception before a child exception like number format exception, the child block will never run. That's because every number format exception is also a runtime exception, so it gets caught earlier. Java detects this situation as unreachable code and throws a compile time error. The correct rule is simple: always write catch blocks from the most specific to most general. Put a narrow exception first and broader ones later. So Java 7, it also introduced multi-catch, right? So where one catch block can handle multiple exception types using a pipe. For example, catch IOException pipe SQL exception E. In this case, the exception variable E is implicitly final and cannot be reassigned. Okay. So if you see the code here, so first block is correct order. So first block integer.parseInt ABC, right? So this line throws a number format exception. Now Java works down the catch blocks from top to bottom looking for this first match. The first catch is number format exception. Does it match? Yes. Number format exception is exactly what was thrown. Java executes this block and prints number format error. The remaining three catch blocks are completely skipped. Notice the order we have here, right? Okay, so we have first number format exception it's the most specific. Above it is illegal argument exception, which is its parents. Above it is runtime exception, and at the bottom is exception, the most general catch-all. So this is the correct order: most specific at the top and most general at the bottom. Then we have catch runtime exception E, and then catch run number format exception E. So this will be a compile time error. Why? Because runtime exception is at the top. Number format exception is a runtime exception. So every number format exception is also a runtime exception. So runtime exception would catch it first every single time. Number format exception block will never execute under any circumstances. So Java recognizes that this is a date code and gives you a compile time error. Okay, so unreachable catch block. So compiler is telling you that this catch never can be reached. So fix your order. So this is not a runtime problem. It fails at compile time before the program ever runs. Why this rule exists? Think of the catch block like a funnel. So you want the narrow filter at the top catching the specific cases, and the wide filter at the bottom catching everything that slipped through. If you put the wide filter first, then nothing reaches the narrow ones, right? So that's why. And then multi-catch, Java 7 and above, it was introduced in. So we have catch IO exception, pipe, SQL exception, E. Sometimes two unrelated exception types need the exact same handling code. Instead of writing two identical catch blocks, Java 7 lets you combine them with a pipe character. One block, two types. One important detail is that the variable E in a multi-catch is implicitly final. You cannot reassign it inside the block, and the two types must be unrelated. You cannot use multi-catch with the parent and its own child, because that would make the child redundant. Okay. So here finally always executes, right? So finally block runs no matter what happens in the try and catch blocks. This is a key rule, and with one important exception. If the try block finishes normally, finally still runs. If an exception is thrown and caught, finally runs after the catch. If an exception is thrown and not caught, finally still runs before the exception propagates. Even more surprising, finally runs even if there is a return statement inside the try or catch. Java prepares to return, but before actually exiting the method, it executes the finally block first. So there is only one exception to this rule. If System.exit is called, the JVM shuts down immediately. In that case, finally does not execute at all. Okay, so if we see the code here, we see that there's a block try system, and that's the first block, try system.out.println try, and finally system.out.println finally. Okay, so no exception here. The try block runs cleanly, prints try and completes. You might expect the method to just move on, but before it does, finally runs. It always does. Output is try and then finally. Second block, exception thrown and caught. So we have try, throw new runtime exception, catch runtime exception E, and system.out.println catch finally, then system.out.println finally. So here an exception is thrown. The catch block handles it and prints catch. Now you might think we are done, the exception was handled, execution continues, but finally still runs. Output is catch, then finally. Finally does not care whether an exception happened or not. It runs either way. Okay, we have to remember that. And we have the third block, which is static int method, try, return 1, finally, system.out.println finally. This is one that surprises most people, right? The try block hits a return statement. Normally return means stop everything, hand the value back to the caller, right? But finally gets one last word before that happens. So Java notes the return value of 1 and then run the finally block. Finally is printed. And then only does the method actually return 1 to the caller. So the output you see in the console is finally printed first, and then the caller receives 1. The return is delayed until finally finishes. Okay, and System.exit, fourth block, right? So try System.exit, finally System.out.println never. So this is the only one and only exception to the always run rule of finally. Okay, so System.exit does not throw an exception, it does not return, it tells the JVM to shut down immediately, and when the JVM shuts down, there is no finally, no cleanup, no nothing. The finally block is simply never reached. Okay, so never is never printed. We have to remember this. So the practice question here, let's trace this step. Let's go step by step. We enter the try block, try is printed, then we hit the line int x is equal to 10 by 0, integer division by 0 throws an arithmetic exception immediately. Everything after this line inside the try block is skipped. We never reach any code below it inside try. Java looks for a matching catch block. It finds catch arithmetic exception that matches exactly. We enter the catch block and catch is printed. Then we hit a return statement. Java notes that we want to return from this method, but but before it actually returns, finally gets to run first. Finally executes, finally is printed. Now the return from the catch block completes. The method exits, right? The last line System.out.println after this never executes. The return inside the catch block already determined that the method is exiting. After is only reachable if no exception was thrown and no return was hit. Neither of which is the case here. Okay, so the complete output is try, catch, and finally. 3 lines and not 4. Okay. So thanks for your time. We have such 1624 practice questions in javalearn.clustermicro.com. You can enroll yourself there. We have 29 full-day practice tests there and timed exams and fully cloud native platform. Thanks for your time.